Good morning dear students. Today we will see properties of the molding sand. In the last lecture only we have started this bit, but today we will revise few of the points and then we will continue with the same point. Now various properties of the molding sand are need to be studied before selection of the molding sand for a particular application. Now few of the important properties are mentioned here in this PPT. Those are permeability, refractoriness, dry strength, hot strength, green strength, flowability, cohesiveness, adhesiveness, fineness, durability, bench life. All these are the few important properties of the molding sand that need to be determined and as well as studied before selection of the molding sand for a particular application. Now one by one we will see all those properties. First property is refractoriness. Molding sand must be refractory in nature. Refractoriness means ability of the molding sand to withstand very high temperature of the molten metal without fusing, without burning, without losing its properties. That property is called as refractoriness. Next one is the permeability or porosity. It is ability of molding sand to allow the flow of gases to escape to the environment. I told you in the last few lectures that green sand consists of water particles, and when that sand is exposed to very high temperature of the molten metal, suddenly water is converted into vapors, and that vapors must be escaped to the environment. For that purpose molding sand must have a permeability. Again, molding sand is consisting of few of organic matters, like the organic matter generated due to decomposition of biodegradable waste. These organic matter is also going to burn when it comes in contact with very high temperature of the molten metal, and due to burning of that gases are produced. These gases must be escaped to the environment. For that purpose molding sand must have a permeability or porosity. Molding sand should be porous in nature. Next is green strength. Strength of the molding sand in a green condition is called as a green strength. Green condition means when that molding sand is having moisture content. I told you green is not color of the molding sand. Green is state or condition of the molding sand, which indicates molding sand is moist. Molding sand contain water particles, and sand that contains the moisture is called as a green sand. The strength of sand in a green condition is known as a green strength, because we are preparing the mold cavity in the green condition. Again that mold cavity is poured in green condition itself. Understood? Now after preparation of the mold cavity, that cavity has to travel some distance on the roller track system, and during that traveling of the mold cavity by using that roller track system, it must not damage, it must not damage, it must retain its shape, it must retain its shape, and that shape is retained because of green strength to that molding sand. Next one is dry strength. When molten metal is poured in the mold, the sand is quickly converted into dry sand due to heat of molten metal. Dry sand means absence of moisture. When I will pour the molten metal inside the mold cavity, suddenly water is converted into water vapors, and that sand is converted into dry sand. Dry sand, and that sand will not lose its shape. That mold cavity will not change its shape, because that molding sand is having a dry strength. The strength of the sand possessed by it in its dry or baked state is called a dry strength. At this stage, the molding sand must possesses the sufficient strength to retain the exact shape. Exact shape of the mold cavity is retained during the dry condition also, because that molding sand is having a dry strength. Next strength is hot strength. Hot strength means what? The strength of the molding sand above 212 Fahrenheit temperature. The strength of the molding sand above 212 Fahrenheit temperature is called as a hot strength. Next is flowability. Ability of molding sand to behave like a fluid when it is rammed, and is known as a flowability. After ramming, the molding sand must reach to each and every corner of the flask. That's why molding sand must have highest flowability possible. It should occupy each and every space inside that flask. That ability is called as a flowability. And collapsibility means ability of the mold cavity to get broken down easily after the solidification of the molten metal. After the solidification of the molten metal, mold cavity must be easily broken down, and that ability is called as a collapsibility. Due to collapsibility, what will happen? Very less efforts are required for the operator to break down the mold cavity. Please understand, this is very important. Collapsibility means ability of the molding sand to broken down easily after solidification of the molten metal. Now why we have to break? I told you in the last few lectures that the casting is removed from the mold cavity after its solidification by breaking the mold. We have to break the mold which is made up of sand, and after breaking we have to take out the final casting out from that mold. Now ability of the mold cavity to broken down easily after solidification of the molten metal is called as a collapsibility. Again it depends on the amount of ramming. रॅमिंग करण्यासाठी लागणारं फोर्स जर आपण वाढवलं, इफ व्हॉट इज स्टँडर्ड प्रॅक्टिस 3 times I have to ram from the top, 3 times I have to ram from the bottom, and if I will increase the number of ramming, at that time collapsibility will be less, and as a collapsibility is less, more amount of pressure I have, more amount of force I have to apply to break the mold cavity. This is collapsibility. Next is cohesiveness.